Continuing on graphs, this section is called Graphs That Enlighten and Graphs That Deceive. And so what we're going to be doing is expanding our exposure to graphs that display data, whether it's large, amounts of data, or small. Each graph is a different approach approach to expression of data for effect or, as the title said, enlightenment. So let's begin with one of the easier ones, which is a dot plot. A dot plot is a graph of quantitative data, that means countable, in which each data value is plotted as a point or dot above the horizontal scale of values. Dots representing equal values are stacked. And you can see this example. And here we're having pulse rates of males. And you can see that we have an extremely high count at about 68. And then another one that handles itself at 71. So the dot plot is a visual, countable graph. Unlike gram, is a larger set of data. And by being a larger set of data, you can analyze more intuitively for each rather than a class, individual. So we can see the repetition of a specific number or determine one that we want to evaluate. So it says here, it displays the shape of the distribution of data. That is true. It is usually possible to recreate the original list of data because it's by data value. All right. So we have some very simple, this homework is very, very simple. And we have the volumes of soda. And the sodas are in ounces. So we're looking here, and it looks like the lowest is 50, and the largest looks like 85. So we're going to say this is 50, 55, 60, 65, 70, 75, 80, 85. And that's about as far as I want to go. I don't see a 90 in there. And the beauty of this dot plot is you can go, you don't have to sort the data. not important because you're graphing one at a time. Actually, we're still going to say plotting. Okay, so let's take the first one, 75. So on 75, I'm going to put a dot right there. Then the next one is 65. On 65, oops, sorry. On 65, I'm going to put a dot there, about the same size, or try to. Another 65, so I'm going to put a dot there. Then another 70, and I'm going to put a dot there. Then a 50, and I'm going to put a dot there. Then a 70, another 70, so I'm going to put a dot there. 75, so I'm going to put a dot right there. Then an 80, and I'm going to put a dot right there. And another 70, another dot right there. And an 85, all right, so I got a dot there. And a 75, so here I go with a dot there. Another 70, a dot there. And an 80, and a dot there. And the last one is a 70. All right. So we can see that we've got a possible outlier. It is the lowest and separated from the rest. Of the cluster, around 65 to 85. So the majority of the data is pretty much aligned with this grouping. And all of a sudden, we can recognize an outlier using this dot plot. All right. So here is our calculator notes. And what we're going to do is learn how, again, to enter data. Now, we have this in a previous lecture, and but I always like to mention it just to make sure everybody's on the same page. So we're going to do a stat key, second row, third key, to a new window. Then we're going to see that edit is highlighted. And from that, we need to choose number 1 by enter. Then we're going to view lines 1 and lines 2, etc. We're going to use an up arrow if there's data in any of the lines so that we can do a clear enter to erase. I've stated that it's between, the up arrow is between, underneath I should say, trace and graph. Enter each data value in line 1. Then you do a second mode. Both keys are on row 1 next to each other to get to the home screen. And that's where we want to be in order to give it a command. Now we want to sort the data for frequency tables. All right. So as we do this, we're going to, we've already entered it in line 1. So we're going to do a stat key, and we're going to do number 2. Sort A, which means ascending order. That means from small to large. Now we use this for the, we used it for the frequency table as a frequency tables, and now we're going to use it for the stem plot. All right, and then we will appear in the home screen, and then you must identify with a second one that we want line 1 assorted. And then we hit enter, And then what we do after that is go back to edit and read. So what we're getting ready to do is a stem plot or a stem and leaf plot. So this represents quantitative data by separating each value into two parts. The stem, which is the tens or hundred values, and then on the leftmost digit, and then the leaf are all the last digit of the number in ascending order. It shows. Now, what is a stem plot? It's another way of looking at a histogram, but using digits. And what this does, it gives us an advantage as to what the physical numbers are that fit in each of the classes, because these are grouped in tens because of the 10, 20s, 30, 40, and so on. It also shows us the shape of the distribution of data. And we can always rewrite all the original data values. It can't be used for massive amounts, but it can be used for a nice sample size. And everything is arranged in order. So what we have is we want to construct one. And I've done a chart, and this is the height of uh, eruptions. All right, so I got that little thing there. And here they are. So let's get out our calculator and we'll get started on what we want to do with these guys. So I'm going to go to my calculator. I'm going to come over here and let me move it down so everybody can see it. Let me see. I got to make it a little bit smaller. So let's see now. There we are. So you can see my input. So I'm going to clear everything on my home screen and I'm going to hit the stat key. I notice this is edit and I want to edit, so I hit enter. And I've got stuff on line 1. I'm going to move my arrow up and do a clear enter. When I do a clear enter, it erases all of the data. So I'm going to enter the data as I see it. And there you can do it horizontally or vertically. It does not matter. So I'm going to do a 67. And remember, garbage in, garbage out. 32, 50, 90, 80, 50, 40, 70, 50, 66, 77, 55, 50, 65, 68, 60, 75, 70, 44, and 89. So as I enter my last digit, it says 21. So there should be 20 digits that I've entered, numbers. So there's 1, 2, 3, 4, 1, 2, 3, 4, 5. So there's 20 data. And I took my time, so I feel that I did a fairly good job of not having my eyes jump. So now, what do I want to do? Well, I can go always to second quit and get on the home screen if I want, or just simply hit stats and I want to arrow down to sort and I enter. It pastes it on the home screen. Then I'm going to do a second one for line 1, and I'm going to enter, and it says done. So when it says done, it means sorted in ascending order. So now what I'm going to do is go to Stat Edit and read my numbers. But let me move down a little bit. Okay, so my first number is a 3, and then 40, 50, 60, 70, and 80. All right. So now I write the last digit of that 2-digit data. So the first one is 32. Well, then I'm in the 40s. So it's 40, 44. Notice I'm only putting the last digit. Then it goes to 50. 1, 2, 3, 4. Let's see, 1, 2, 3, 4. I got 4. I'm still in the 50s. I have a 5, 55. All right, so I'm going to move my all the way to the bottom till I get through with the 55. I'll start. Now my column is with the 55. Now I'm at with my 60s. I have a 0 for 60, then a 65, 66, 67, 68. All right. Then I go into the 70s. So I'm going to move my arrow back down to get, oops, too far, didn't I? Too fast is what I did, because I'm near the end. And there's my 20. Okay, so now I'm at my 70s, and I put 70, 70, 75, 77. And now I'm in my 80s. I have an 80, an 89, and I have 190. All right, so I have entered all of my data, and hopefully I did not mess up and get the wrong digit in. Uh, Let me look again. Let's see what I have. Yes, I did not mess up. It's pretty good. All right. So now, what does it look like? Well, what does it resemble? Well, we can see that it goes low, reaches a peak, and goes back low. So it's pretty much a normal distribution, approximately. So the question is, the two values closest to the middle are. Okay, so remember it was 20 data. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there's 9. So now I'll go to the top. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these two numbers are the two center numbers, and they are 60 and 65. And now those are the two center numbers. They all have 9 surrounding it, and you saw how I did it. So it's very beneficial. The stem leaf gives you an eyeball of data values as well as structure. This next graph is very specific. It is called a time series graph. It is used to graph large periods of data that are collected to show the tendencies for the impact of whatever study they're doing. So this graph is has a quantitative data again that has been collected at different points and times, such as monthly or yearly. It reveals information about trends over the time. They do this a lot with global warming. They do it with the sunspots and all kinds of stuff is what they use this one. And this one is law enforcement fatalities. Law enforcement fatalities. And it is from the year of 1985 to over 210. So we're talking about maybe uh, 2020, suppose. Okay. So the dots are for each of the years and what is happening, and then they connect the dots to show a trend. All right. So let's see what we have here. We have the accompanying data represents women's median earnings as a percentage of man's median earnings. So this is how much a woman is earning against a male's income for recent years, beginning with 1989. Is there a trend? Well, yes, look, it was 59%. It slowly increased, decreased, increased, 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 decreased, 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 increased, decreased, increased, increased. So there is a tendency toward up and down, and usually it's due to the political mood of the country. Well, they want us to figure out which graph suits this continual change from 1989. So keep in mind it's a percentage. Well, the first graph starts at 1989 being, it looks like, let's see, this is 64, 6, 8, 10, nope. So that is 64, 65, 66, 67, 68, 69, 7. So each one is 1. So this one is 69. Well, this one's wrong because the first entry was 59%, more or less. So that graph does not suit it. Well, this one could be 59 and some because the data said it was 59 and 6/10 because almost 67, 57. If I could speak, you'd be in good shape. It's almost 60%. So we can see that this is 9 and this is 60. So this one could be it. What about this one? This one starts at 59. This one could possibly be it as well. So it's between these two. So let's look at the next one. The next one says 60 and change. So this one's 60 and this one's 60. Both of them are 60. So that's good. And the next one is a spike. And the spike is 62 and a half. So 60, 61, 62, and a little bit. Okay, this is 60, 61, 62, and a little bit. This one's closer. But let's keep going. Let's see what we have. And no, that's it. Let's look at the high one. Let's look at this one. And this one is 1997. 1997 is 67. So let's look at that. 64, 5, 6, 7. This is our graph, our timeline graph, our time series. That's what you'll do on the homework. This one won't appear on the exam, but is something that you must recognize. So then it asks us, what are the trends? Well, we can see that it is trying to achieve some kind of increase of some form with some intermittent dropping. There is a general upward trend, though there have been many small down years. An upward trend would be helpful to women so that their earnings become equal to those of men. And that is the correct answer. This one says no trends, but that's false because it is got some very definite peaks. And the third one says there is a general downward. Well, no, there is no downward. There's intermittent setbacks, but no downward. So now I didn't do anything on the bar graph because it is primarily categorical. That means colors, types of vehicles, and everybody knows about a bar graph and the quantities of it. So I didn't do any examples on the bar graph. You just know that on those there are graphs. Now this next one is interesting. It's called the Pareto. I think I'm saying it right. Pareto graphs. The Pareto graph chart is a bar graph for categorical data. Again, that's like a bar graph, but it's different, with the added stipulation that the bars are arranged in descending order. Descending, large to small. Oops, I better put the plural. In doing this, we focus on what is important in the structure of these Pareto charts. The Pareto charts um, show relative distribution of categorical data so that it's easier to compare the different categories and see the order of them. It draws attention to the more important categories. So here we have a study conducted to determine how many people get jobs. The table lists data from 400 randomly selected subjects. And they said construct a Pareto chart that corresponds to the given data. If someone would like to get a job, what seems to be the most effective approach? So first, let's look for the highest, networking. And it had 271 counts of subjects that said that that was the most important. Notice it uses the capital N reference. Okay, the next larger is 60, and that one is help wanted ads, and that's an H. The next one, so we got that one, is 42, and 42 is mass mailing. I don't know how mass mailing works because you're putting so much out there. Nobody's really going to read it unless there's an opening. So I'm not understanding the mass mail out. And the last one is executive search firms. When you pay money to find you a job, they look for the job you'd like, and then and they seek employment for you. Now remember, we start with the largest, so it's not these two. So it's looking between this one and that one. So we're talking N, H, M, and E. So N, okay, it's not that one. It's this one, H, M, and E, and that's the one. Uh, if someone would like to get a job, what seems to be the most effective approach, and that is networking. That means using your friends from prior employment or friends in general who went to college with you, and seeing if there's openings uh, within their uh, uh, employment area. So D, it would be D, networking. All right. Now a pie chart has to be, you can only do these accurately using a program. So I'm not going to study this one. There's a lot of math in it, and pie charts are done by hitting a key after you enter data, and it'll do it for you. Now, one of them that is important is the frequency polygon. a polygon is a uh, multi-variable, degree variable structure. So in this one, we're talking frequency polygon, which means multi-changes within the structure of the data. The graph using a line segment connected to the points located directly above the class midpoint values. Midpoint. So we're still talking classes. Sorry. And we're using the midpoint, which is the low plus the high divided by 2 gives you the midpoint. And that's more indicative rather than giving you a histogram. So it removes a histogram, but it shows you the change in the values of those classes. The frequency polygon is very similar to a histogram, but a frequency polygon uses line segments instead of bars. A variation of the basic frequency polygon is a relative frequency polygon, which is percentages. And we studied those too in our frequency tables, which uses relative frequencies as proportions. So we just want to look at which one this is. So tornado F scales, we have 0 through 4, just like earthquakes have their own numbers. This is a measure of tornado uh, strength. The given data represents a frequency distribution of F-scale uh, intensities of recent tornadoes. Use a frequency distribution to construct the frequency polygon. Does the graph suggest that the distribution is skewed? If so, how? Okay, so we're talking about this kind of information. So we're saying 27. Okay, so we have 27, 16, 1, 2, and 2. So here we have our 1, which is 16. The largest is 27. And this one, it looks like it's this guy right here, because this is the closest to 27. And then 2, right there is 2. So this one is not. So it is skewed to the right. It's skewed to the right. All right. This is our last problem. And again, we're finishing up the discussion with a short amount of data here. Listed below are the numbers of unprovoked shark attacks worldwide for the last several years. Why is it that a dot plot of this data would not be very effective in helping in understanding the data? Which of the following graphs would be the most effective for the data? Dot plot, stem plot, time series, Pareto, pie chart, or frequency polygon? Well, first off, we see that there is little data. And if we were doing a dot plot, we would see if we had repetition. And 81, 98, 73, 76, 83, 82, 79. No, no repetition. Of data values. So a dot plot is not good. So what is the problem with this? Well, first off, it's too small a database. Okay, so the spread of the data is very small. Yes, it is. So it would be nearly impossible for any differences when represented graphically. Even though the data are numeric, there's actually, no, that one's wrong. There are several duplicate, nope, there's no duplicates. It's too small for a dot plot to reveal important characteristics of the data. The closer of it is the A. Yes, the D sounds good as well, but it's, for me, it's the A. Okay, so what would be a good one? And that would be a time series. A time series would give us a picture of what these shark attacks are doing for that period of time that is involved in it. All right, guys, you're ready to do the homework. You're armed and dangerous. Thank you for listening.